Hello everyone. Today's topic is about impact of economic growth factors on CO2 and energy consumption. We are from Group 25 and I am Bhushan Raj Joshi and my partner for this project is Eka Suri. Before we go on with the slides, here is how we have divided our presentation sections. First, we will look into why CO2 and energy consumption research is required. Next, we will look into objective of the research, model description, analysis and results, and finally we'll look into the conclusions and future enhancements. We believe facts and figures are the best way to learn new things. And here we have included chart, figures, and graph to explain you why CO2 and energy consumption research is vital. Firstly, in the left-hand side, you can see that before the Industrial Revolution, CO2 concentration was about 280 ppm, which has increased exponentially to more than 400 ppm by 2020. In the right-hand side, you can see that energy consumption was well below 20,000 terawatts-hour before Industrial Revolution, which has increased exponentially by 2019. The increase in energy consumption and CO2 concentration causes rise in temperature. Here we can see that in 2019 it was recorded the second warmest year. The rise in temperature has several consequences. One of its major impact is rise in global sea level. According to NASA, rise of sea level by 26 inches or by 2100 will cause significant problem in coastal areas. In the right figure of world map, the dotted point represents the coastal cities of more than 1 million people. So, due to rise in sea level, it will affect millions of lives due to floods and climate change. While the other consequences are decline in Arctic sea ice, which will cause disappearance of polar bears, seals, whales, and other animals, decline in global crop yield, decline or loss of plants and animal lives, disappearance of coral reefs, exposure of severe heat by world population, and scarcity of water. To tackle those challenges, multiple research has been done to find the relation between GDP, CO2 emission, energy use, agriculture, and multiple other factors. So what we are trying to do in our studies is use all those multiple economic factors and find its relation with CO2 and energy consumption. Apart from that, we'll also look into multiple services and its relation with GDP to finally build a reliable regression model for high-to-income countries based on Asia only. Now, let's look into the model description. Our model consists of low to high income countries from Asia. Those are Afghanistan, Uzbekistan, India, Indonesia, and Japan. The sample data for this model are from 2000 to 2019 to find the relation between CO2 energy consumption with macroeconomic variables. The data sources for this model are mostly from Asian Development Bank, while the remaining are from World Bank and Global Energy Statistical Yearbook. For our research, we have used three models. The first model has dependent variable as GDP, while the independent variables are agriculture, manufacturing, and services. For our second model, dependent variable is CO2, while the independent variables are GDP, export, import, energy consumption, and energy production. Both of these models are based from paper by Alam 2015. For our third model, we are using dependent variable as energy consumption with independent variable as GDP, CO2 emission, total population, capital, and financial development. This is based on paper by Saiti and Hamami 2015. Here we can see the variables used in the models with the symbols, units, and types. There are about 18 variables. Now looking into the equations, For the model 1, we have used natural log transformation for all the variables. For model 2 also we have used natural log in all the variables. The use of transformation was done to improve the model and remove the nonlinearity. While for equation 3 we have just used the normal variables. Here in the equations, I and T represents country and time respectively. Now, let's move on to analysis and results. Firstly, descriptive statistics. For model 1, we can see that there are 83 sample data and logarithm of SRA, which is service of retail estate activities, has high standard deviation. For model 2, the sample data are 57, while we can see that import and export has similar mean. And lastly, for energy consumption, there are 44 sample data. In this, capital and GDP have significantly high values because units of those are in millions. For the regression, all three models have high R-square. High R-square represents small differences between the observed and fitted values. It also represents high variance of dependent variable that can be explained by independent variables. For the coefficients for GDP model, we can see that there is a positive relation of GDP with agriculture, manufacturing, and different services like information technology, financial and insurance, real estate activities, and other services, while there is a negative relation between transport and storage service, wholesale and retail service, public and administration and defense service. Apart from that, manufacturing, service like wholesale and retail, service like finance and insurance are not statistically significant, which means at 95% confidence level, if the p-value is less than significant level of 0.05, then only the hypothesis is statistically significant. While for CO2 model, the coefficient relationship for export and energy consumption is positive, while for GDP, import and energy production is negative. Also, import is not statistically significant. For coefficient for energy consumption, there is a positive relation with total population, financial development and GDP, while negative relation with CO2 emission and capital. CO2 emission, capital and GDP are not statistically significant. Now let's look into the analysis of residuals, starting with GDP. The normality test for the residuals of GDP was done using Shapiro-Wilk test. The significance value for it was 0.05, right at the borderline, but we assumed it as normal, and we have confirmed this with Professor as well. We have also plotted a scatter plot for residuals versus fitted values, which did not show a funnel shape. Also, a vector of random variable is heteroscedastic if the variability of the random disturbance is different across elements of the vector. So, heteroscedasticity is not present. From the analysis of residual for CO2, we can see that Shapiro-Wilk's significance value is 0.777, which shows that the distribution is normally distributed, which can also be seen in the histogram. From the scatter plot of residual versus fitted, we see that there is no funnel shape and absence of heteroscedasticity. From the analysis of residual for energy consumption, Shapiro-Wilk significance value is 0.108, which shows that the distribution is normal. And from the scatter plot, there is no funnel shape, so heteroscedasticity is not present here as well. Now let's finally move on to conclusion and future enhancements. From the results, we can see that for all the three models, there are multiple independent variables that are statistically significant. The residual plot for all the three models are normal, and there is absence of heteroscedasticity. The R-square is high for all the models, so the variability independent variable are explained by independent variables. The GDP has shown statistically significance with only CO2 emission, while for energy consumption, GDP has not shown statistical significance. Now let's look into problem faced. First challenge was due to using multiple sources of data like World Bank, ADB, and Global Energy Yearbook. Unit conversion was especially a problem for ADB data as the country-wise currency was used for those data. For example, Japanese yen was used for Japan data, Indonesian rupiah was used for Indonesian data, and so on. Also, growth rate had to be calculated for some of the data, which created another problem. There was missing data as well for low-income countries like Afghanistan, as a column like capital and energy consumption was missing. So we used neighboring country like Uzbekistan to make the model more reliable. There was also existence of outliers in the data. The non-linearity of the model was solved using multiple transformation like log base 10, natural log, square, cubed, inverse, and other transformation for dv and iv as well. Also, removal of some independent variable was done to make the model more reliable. There was also existence of high intercorrelation between some independent variable, which was shown by variance inflation factors. These can also be solved using transformation. High value of R was also another problem. This might be due to overfitting, bias estimation, or trend in time series data. The trend in time series data can be overcome by including time-related variable in the regression model. Apart from this, there were some challenges in team coordination and meeting schedule, as all of the talks was done online and there was time difference challenges as well. Looking into the future enhancement, relationship with other independent variables like renewable or sustainable energy, carbon tax, and government policies can be looked into in future research to provide new insights and provide an effective solution to overcome the challenges in energy consumption and CO2 emission. Further addition of more country or sample data can provide a better or reliable model. Also, environment degradation with its rise and fall can be tested with using EKC curve. So here are the references that we have used in our presentation. Thank you for staying till the end of the presentation. If you have any queries and feedback, please send us email at the email address listed out over here, or you can even send us feedbacks through Google Forms or any anonymous messages. Thank you again and have a great day.